All right, in 6.2, we're talking about titrations and buffers. Both of these things we've mentioned at this point, but we haven't gone into a lot of detail. Some definitions. Titration is a quantitative analysis technique in which a solution of a known concentration, known as the titrant, is added to a solution of an unknown concentration, the analyte, until the reaction is complete, or the stoichiometric equivalence point. Often, when an indicator changes color, which is the experimental endpoint. Example 1, propanoic acid HC3H5O2 was titrated with a 0.1 molar sodium hydroxide solution, Ka of propanoic acid 1.3 times 10 to the minus fifth. So first off, we can draw a net equation here. So propanoic acid, which is aqueous plus hydroxide, and you're going to end up with propanoate and water. Try this again. First thing you want to do is figure out the number of moles of each of these reactants. So go ahead and get started on that, and I'll be right back. Okay, so we have 25 milliliters of 0.1 molar sodium hydroxide. Right. Okay. So for the stoichiometry step, you can fill out a big ice chart if you want. I probably wouldn't. You know which one's going to run out first, right? Sodium hydroxide or propanoic acid? So sodium hydroxide. So here's how we can make it a little shorter. 25 milliliters. And the hydroxide concentration is 0.1 moles per liter or per 1,000 milliliters. And then we know the mole ratio. It's 1 mole of hydroxide for 1 mole of propanoic acid. And so this tells us how many moles of propanoic acid are going to be used in the reaction. Could have figured out the same thing using an ice table. That's probably more work than doing it this way. So the concentration of the propanoic acid Here's our moles. What's our volume going to be? Okay. So 63 was the total. That was it.
65.
65. That's the total volume of the solution, and that's good. Here's what it was asking us. What was the concentration of the original acid solution? And so it is 65, but when you're looking at the original solution, how much was there? 40 milliliters, or 0.040 liters. And so the original concentration was 0.063 molar of the propanoic acid.
What the 0025 is how much used.
Yeah, so here's what happened. We didn't know the concentration of this, but we did know that they react in a 1-to-1 ratio, right? And so here's probably what this looks like. I've got my flask with volume is known, concentration is not known. And then I've got this burette and it's sodium hydroxide. We know how much volume we added, so it probably went from here to here. The volume was 25. So that's known. Concentration was 0.1, which means we knew moles. And so we started with this information, and you can see that here. Volume times concentration told us, at this point, we knew moles of hydroxide that reacted, and we knew that there was some left over. We didn't really care how much was left over. Yeah. So this mole ratio told me how many moles of this we actually had. And this is how you're going to figure out the sodium hydroxide on Wednesday or Thursday. And so, yeah, this was the original solution of the acid. And so that's step one. A lot of times you just have to figure out what the concentration of your reactant is based on the cover. So when we do this in the lab, the sodium hydroxide concentration will be our unknown. We're going to know the volume. We're not going to know the concentration. But down here, we'll know everything about this acid, which means we could use this stuff to calculate this one. It's going to come back to this example. You just have to realize that, you know, what do you know, what do you not know? It doesn't matter if you know about this stuff or if you know about this stuff. As long as you know one of them, you're set. So maybe put a big star here. Come back to this in the lab. That'll be helpful. Experiment 2, suppose a 60 milliliter sample of 0.15 molar propanoic acid solution is obtained. How many milliliters of 0.1 molar sodium hydroxide is needed to titrate the solution to its equivalence point and its halfway point? What is the pH of the solution at its equivalence point and its halfway point? So again, rather than using an ice table, you can go through this with the basic stoichiometry. So here's my propanoic acid. We know we added 60 milliliters. We know that it's 0.15 molar, which is 0.15 moles per 1,000 milliliters. And those will cancel. So we know moles of propanoic acid, and then you can move on to your mole ratio step, and it's 1:1. Quick note, I would not skip out on mole ratio steps. There was one question on the mock exam where the mole ratio was actually worth a point. So don't skip out on it. Whether you did it like this or whether it showed up in an ICE table, the ICE table kind of implies a mole ratio because you see those like minus 1x and plus 2x type things. That's the mole ratio step. So how many milliliters of sodium hydroxide do we need? And it is 0.1 moles per liter, or 1,000 milliliters, and that's sodium hydroxide. So your thousands can cancel, don't put them in your calculator. So here it is. We're going to need 90 milliliters. This is the point where all of the propanoic acid has been reacted. What would we call this point? Is this the halfway point? Is it the equivalence point? Is it none of the above? So here's what we're looking at. When you do the stoichiometry step that shows you basically the end of the reaction for the acid, this is the equivalence point. It's where in the reaction the moles of one reactant and the moles of the other reactant were equal. This is basically the point on the graph where we're shooting almost straight vertical. Calculate its halfway point. So this is the big secret. How do you find the halfway point of the equivalence point? What's half of 90? 45 milliliters to the halfway point. Remember I showed you an important thing about the halfway point. We're going to write it down here. At the halfway point, pH equals, what did it equal?
pKa.
pKa. Very good. pH equals pKa. We actually know the Ka of this acid. So P means negative log, and the Ka of this acid was 1.3 times 10 to the minus fifth. And so your pH at the halfway point and your pKa are 4.89. Let's write down something else. At the equivalence point, what do we have in this solution at the equivalence point? Do we have any propanoic acid left? No, it's all reactive. Do we have any hydroxide left? No, it's all reactive. Okay. Do we have any propanoate left? It's the conjugate base. So we have propanoate ions left. What else is in the reaction? Water. And we always just leave that out because there's so much water there already. So this is the only thing left. We only have, right in the word only, we only have propanoate left in solution. So this is probably going to lead to a problem, right? So we have to do another step. Okay, so the initial moles of propanoate, we had, 9 times 10 to the minus third. We didn't actually write it down. Let's write this down now. Let's switch pages. So the initial moles of propanoate. So we had 60 milliliters, and what was the concentration? 0.15. That should be 9 times 10 to the minus third.
Could you not just write that one as the mole ratio?
Huh?
Could you not just write that as the mole ratio?
As the mole ratio. What we're doing here is finding moles for an ice table.
Okay.
Yeah, sorry, I
Okay.
probably didn't say that out loud. We're looking for moles to put in an ice table. And so for the equilibrium step, you have to have a starting number of moles or a starting starting concentration. So this also equals moles of the propanoate at the equivalence point. So just stick with me for a while. This will make sense eventually. Here's our moles. Our total volume here, we had 60 of the propanoate, and let's see, we added 90 of the sodium hydroxide. So 150 milliliters or 0.150 liters. So there's our concentration. All right, let's pause. We'll pick up there tomorrow. I don't want to run you through your SRT. Probably have to back up just a little bit.